Hello everyone, and welcome to Module 8 of this training course on the Internet of Things for Hydrologic Measurements. My name is Douglas Nyole. This module is part of a series of modules that have been prepared for this training course. In Module 8, we will be building a LoRa Wide Area Network Nano Gateway for data transmission. In the previous modules, we briefly discussed the different communications options that are available. Specifically for PyCom products, we mentioned that there are 5 communication options. The first one is Bluetooth. Then we also have Wi-Fi, LoRa, that is a long-range wide area network, Sigfox, and NB-IoT or LTE. Other microcontrollers in the market also have the option of GSM. Here, you get to use a regular SIM card that you insert into the microcontroller, and it's able to use the regular 3G or 4G networks like the mobile phone to transmit data. Unfortunately, PyCom products don't have this option yet. They may introduce it in the future. We invite you to spend some time to look at this table and understand the properties of the different communication options, that is with regards to the range, energy consumption, frequency band, and data speed. For this course, we'll be specifically using LoRa, that is a long-range wide area network. The properties of this network is that they cover 5 to 10 kilometers. Therefore, it's long range. That's why they are called long range. They are low in energy consumption, are license free, but the data speeds are low. Most recently, NB-IoT or the LTE has been introduced by GSM companies. This option uses the regular GSM network. The advantage, however, is that as opposed to the regular GSM, which is high energy consuming, the new one, NB-IoT, is low in energy consumption. It also covers a wide area, 30 kilometers, is high in data speed, but is licensed. Therefore, you will be required to pay for it, register, pay for it, and use it. NB-IoT is slowly becoming very popular. Many IoT systems are already embracing this network. For now, we are still using LoRa Wide Area Network and Sigfox, but the future of IoT communication will be NB-IoT. In this slide, we present the different pathways followed during communication from the IoT system, that is the sensors and the microcontroller, through to the gateway, to a server, and finally to an application server. Therefore, to the far left, we have the sensors, that is what we deploy in the field together with the microcontroller. We then have a gateway. The gateway is one that receives data and communication from the IoT system that we've installed in the field, that is the microcontroller and the sensors. It then transmits the data through the internet to a network server. From the server, they are then channeled to an application server, and this is where we get to view, visualize, download, store the data. In this figure, we present the positions of the different communication options. We present it in a graph with the vertical axis presenting the data rate, that is the speed, and the power consumption. At the top, that is high power or low power. In the horizontal axis, we present the range. Bluetooth, which is positioned to the bottom left, is a low power consumption option with low speeds of transmission. The option is also short range. GSM option, presented in green, is a high power consumption option with high data transmission speed. The range is also long, so it's a long range option. LoRa, which is positioned to the bottom right, is a long range option. Unfortunately, the data transmission speeds are low, but it also has the advantage of low power consumption. Many IoT systems would prefer using long-range networks, as most IoT systems are deployed far away from each other. Specifically, the LoRa Wide Area Network is preferred. This is a system that is open, or rather free, and implements an open protocol for wireless data transmission for IoT. Other IoT systems may prefer to use Sigfox. The difference between Sigfox and LoRa Wide Area Network is simply the fact that LoRa is open, while Sigfox is proprietary. That is, it is owned by somebody. It is actually owned by the French company called Sigfox. As I mentioned in the previous slides, NB-IoT or LTE are relatively new options that are designed to operate using the GSM infrastructure. So the difference with the regular GSM is that the GSM is high power consuming, while these other ones are low power consuming. NB-IoT is also proprietary, so they are owned by companies, and you will need to pay to register and pay for it before you can use them. The advantage of NB-IoT or the new LTE-M is that they are easy to roll out because they use the existing GSM infrastructure. Sigfox is a network that has also grown relatively fast in the recent years. In this map, you see the countries that have already rolled out Sigfox. So the purple represents the countries, while the blue represents the area within a country that is covered by Sigfox. The reason why NB-IoT and LTE-M is growing relatively fast is that it can coexist with 2G, 3G, and 4G mobile networks, as it is supported by all major mobile equipments, chipset, and model manufacturers. The advantage of this option also is that it benefits from all the security and privacy features of mobile networks. That's why it's becoming more and more popular. In this map, we show the countries that have rolled out NB-IoT and LTE-M. In purple, we see the countries that have rolled out both. Red are the countries that have rolled out only LTE-M, while the blue are the countries that have only rolled out NB-IoT. Here, we see examples of microcontrollers from the PICOM companies that are able to use all these networks. In the upper one, it's able to use Wi-Fi, Bluetooth, LoRa, Sigfox, LTE-M, and NB-IoT, while the lower one is only able to use LTE-M, and NB-IoT. What you see in the lower one is that there's a socket where you're able to insert a SIM card to be able to use this network. Therefore, once you have built your IoT system and deployed it in the field, it should be able to transmit the data to a gateway or an antenna that is located at a specific position. From the gateway, it then uses the internet to connect to a server which is located in the cloud. Together, all these uses LoRa Wide Area Network or Sigfox or LTE-M or NB-IoT. From there, it moves to another back-end server where the data is stored, processed, and the graphs produced, that is for visualization. And at the end, you're able to visualize using your computer or your mobile phone. Having understood the channels followed in an IoT communication system, the question would be, can we do this without using a provider? Yes, it's possible with the LoRa Wide Area Network. Remember in the previous slide, I mentioned that LoRa Wide Area Network is open and free. Therefore, one is able to build their own LoRa Wide Area Network and use it to transmit their data. The LoP4 specifically can be used as an IoT system that is connected to the sensors, but at the same time, it can be built to form a gateway that can be used to connect to the internet. To do this, you require a Wi-Fi so that it can be used to connect to the internet. Once you've built your own Nano gateway using the LoP4 microcontroller, like what you see to the left of the screen, or you choose to buy a Nano gateway that has been already built, like what you see to the right, you may choose to register the gateway in the Things Network. The Things Network is a platform that allows users to register their gateway. So the advantage of this is that you're able to allow others to use your gateway, while you can also use gateways that are owned by others and that have registered within the Things Network. As at February 2019, 2,932 gateways had already been registered with the Things Network. So you see how many people are building their own gateways and sharing it using the Things Network. And as at February 2021, 17,996 gateways had already been registered in the Things Network. You are invited to go to the Things Network and be able to see. I'm sure by now it may be at around 25,000 to 30,000. We will now learn how to build our own Nano gateway using the LoP4 microcontroller. To be able to do this, we need a LoRa microcontroller, a micro USB cable with the USB type A on the other end. We need a computer with Visual Studio Code and PyMaker installed. We need the PyCom antenna and a cable. We need a Wi-Fi connection, and we need the LoRa casing. Of course, we are able to build a Nano gateway without the casing, but to be able to have a proper Nano gateway, it's important that we build our Nano gateway together with a casing so that it can safeguard it. Setting up a Nano gateway also requires a set of 3 MicroPython files. The first one, which we'll call the main.py, that is, or py, is used to run different system boots and calls the library and configuration files to initialize the Nano gateway. Therefore, once configuration is set, the Nano gateway can then start. This file is available in the PyCom GitHub account, but of course it will require some slight modification. The other file that we require is a config.py file. This file contains the settings that are used to configure the server and network that will be used for the connection. This file can also be downloaded from the PyCom GitHub account. This also requires some slight modification. Finally, we need what is called a nano gateway.py file. This is a file that contains the Nano gateway libraries that are used to control all of the packet generation and forwarding for the LoRa data. This file can also be downloaded from the PyCom GitHub account. No modification is required for this file. Once you have built your LoRa Nano gateway, you will need to register it within the LoRa Wide Area Network servers. To do this, you will require a gateway ID. The gateway ID required in this case is a unique 64-bit hexadecimal number that comes with every LoRa device. To obtain this, you will simply connect your LoRa device to your PC, start the Visual Studio Code, and run the script below in PyMaker console. This should generate this code as you can see below. What forms the gateway ID is specifically these digits. In the previous slide, I mentioned to you 3 files that are required when configuring the gateway. I mentioned the config.py file, the main.py file, and the nano gateway.py file. I also mentioned that the main.py and the config.py require slight modification. In this slide, I present to you the config.py file. I will also show you the modifications that are required for this file. In the first section highlighted, the config file has the ability to extract the device ID, which will make the gateway ID by itself. Therefore, you don't have to run the script separately. Next, you will need to provide the Wi-Fi SSID, which is the username of your Wi-Fi, and the password. This is because it will require them to connect to the internet. You will then need to select the LoRa frequency to use. If you are in the EU, then you will need to use this that I have highlighted. However, if you are in another area outside the EU or the US, you will need to check with the LoRa Alliance website for the settings to use. If you're in the US, you will use these settings. Now let's look at the main.py file. This should come after modifying the config.py file. In the main.py file, the first section imports the library that is from the nano gateway.py, the one that is not modified, and the configuration from the config.py file that we have just modified. Also ensure that the settings are right in this file so that it's able to read from the library that is the nano gateway.py and from the configuration, which is the config.py. If everything is set, the gateway can now start. If you have followed the steps in the previous slides carefully, you should now be having a ready nano gateway built from the LoRa. So you should have something like this. Earlier on, I mentioned to you that you may want to join the Things network. This is a network where you get to participate in building a global LoRa wide area network. Therefore, Once you have built your own Nano gateway, you may want to register it with the Things network and allow others to use your gateway while you also use their gateways. Therefore, by doing this, you're participating in building a global LoRa wide area network. To register your LoRa gateway with the Things network, you will first register yourself as a user. And if you're already a user, then you will simply log in. Follow the link below to register, which should display this screen where you get to provide your details and register. Once you've logged into your account, click on the area around your username. You will get a drop-down list. Select on console. In the new page that appears, select the region where you want to register your gateway. If you're in Europe or somewhere around Europe, then you may select Europe. Once you've selected the region where you want to register your gateway, you will see two options. The first one to the left says Go to Application, and the one to the right, Go to Gateway. Go ahead and select Go to Gateway. Next, you will be required to register your LoRa gateway by clicking on the Add Gateway. Once you click on the Add Gateway link, go ahead and provide the gateway ID, then the gateway EUI, give your gateway a name, and provide some description for your gateway. Scroll down the same page and select the frequency plan. In the drop-down list, select the appropriate frequency plan for your region. In my case, the second option is recommended. Finalize the process by clicking on the Create Gateway at the bottom. You may then continue to provide other information and settings required for your gateway registration. For example, the location and privacy settings. The gateway that you've just registered may not appear immediately, but eventually it will appear in the Things network map. Up to this level, you've been able to build your IoT system using the LoRa 4. You can then use the LoRa wide area network to connect to a gateway. And in this case, the gateway is one that we've built in this module. And because you have Wi-Fi connection, you're able to connect to the Things network, which is an online platform, which is located in the cloud. Then using Node-RED and the ThingsSpeak network, you're able to access cloud services to be able to store your data. So what the Node-RED does is that it allows you to reformat the data in preparation for the ThingsSpeak. And at the ThingsSpeak platform, you're able to visualize, carry out quality control, storage, and analysis. The Things network, the Node-RED, and the ThingsSpeak together are cloud services. ThingsSpeak is only able to offer you limited storage. Therefore, to be able to enjoy more storage, you may need to pay for that. And if you don't want to pay for this, then you may consider creating your own cloud services. Thanks, and that's the end of this module. See you in the next module. Bye.